This is a continuation of our last video where we were talking about the sum and difference identities for sine and cosine. I have only 3 examples left, and the last one really is the most important one. All right, so let's take a look at this example. If I compare this to my identities, this looks like the sine of A cosine of B minus the cosine of A sine of B formula. And I want to point out that these two angles are the same and these two angles are the same. So I can replace them with A and B. All right, so I know that this formula is the formula for sine of A minus B. So since A is 100 and B is 10, I'm going to put that into my sine of A minus B formula, and I'm going to come up with the sine of 90 degrees, which I know has a value of positive 1. So that complicated left-hand side of this equation really only equals 1. All right, so let's take a look at this. This matches, if we take a look at our tangent formula, I've got, let's call this A and this A because they match. We'll call this B and this B. So what formula do I have here? Well, it looks like this. Tangent of A times the tangent of B. This is the formula for the tangent of A plus B. So I'm going to replace this with the tangent of, what's A and B in this case? Well, one is 5 pi, A is 5 pi over 12, and B is pi over 4. So when I add those, I get the tangent of 5 pi plus 3 pi is 8 pi over 12, which really is the tangent of 2 pi over 3. Okay, so my reference angle for this is going to be pi over 3. So when I draw a nice reference triangle with pi over 3 here, this other angle is going to be pi over 6. Okay, so this is a nice 30, 60, 90 triangle. If this is 1, this is 2, and this is radical 3, my tangent is going to be opposite over adjacent. So I have a nice radical 3 as my tangent. But again, I forgot 2 pi over 3 is in quadrant 2, and I should have labeled that as a quadrant 2 angle. So tangent is negative in quadrant 2, so it's negative radical 3. We cannot forget what quadrant we're in, right? This is a nice quadrant 2 angle, so I have to apply the correct sign. Okay, this is the last example and one of the most important examples. If we take a look at this, this and this are the same angle. I'm going to call that A. This and this are the same angle. I'm going to call that B. So if I take a look at this, I can rewrite this as tan A plus the tangent of B over tangent of A times the tangent of B minus 1. But that does not match any of the formulas I have. Okay, I know that the tangent of A plus B equals the tangent of A plus the tangent of B over 1 minus the tangent of A tangent of B. So how might I be able to change this identity right here into this identity? Well, it may not be completely obvious, so let's walk through that. What would what would happen if I took and multiplied both sides of this identity by a negative? Okay, I'm going to put that negative out in front of my fraction. And because I'm doing that, I'm going to put the numerator and denominator in parentheses because they are binomials. What would happen if I applied that negative instead of putting it out in front? I have the option of applying it to the numerator or the denominator. So let's apply this to the denominator of this fraction. All right, so that gives us a -1 plus tangent of A, tangent of B. So if I just flip these two bottom terms, I get exactly what we have in our example. Tangent of A, tangent of B minus 1. This is exactly, okay, memorize this because I'm not going to be able to fit the other one up there. Exactly what we need for our example. So I know that this equals negative tangent of A plus B. All right, so we came up with a brand new identity for one of our problems, which is okay. We're allowed to manipulate all of our identities into equivalent alternative forms. All right, so I'm going to erase some of these arrows so I can fit some of this work in. So continuing with this, I am going to plug in 5 pi over 12 for A. 5 pi over 12 for A and pi over 4 for B. I know that pi over 4 is 3 pi over 12. So 5 pi over 12 plus 3 pi over 12. When I add those two, I get 8 pi over 12, and then when I simplify, I get 2 pi over 3, and I think in the last example, we had the tangent of 2 pi over 3. That's a Q2 angle, and we came up with negative radical 3. So I'm going to replace the tangent of 2 pi over 3 with negative radical 3. So in this instance, we get a positive radical 3. All right, so we can always manipulate our identities into alternative equivalent forms so that we can simplify our problems.